Secrets of Castle Hill Basin. Castle Hill Basin in New Zealand. It's the world's most famous tourist destination, filming location, and amazing geology location for all people around the world who are interested in science. Is it handmade or is it real features that we can meet in the nature? Let's talk about limestone formations. On example on Castle Hill, we'll explore how it formed, why it has such a particular shapes, and why we can meet these formations in only specific places on our planet. Castle Hill Basin is located in the middle of the southern island of New Zealand, about 100 kilometers away from Christchurch, the biggest city on South Island. You've seen this location from many photographs from that location, and also everybody who've seen movie Chronicles of Narnia, seen the famous battle filmed at that location, and of course there's a scene set in Lord of the Rings. When many see this area, people are curious how it's been formed. Is it real and natural? And the name Castle Hill was given because of these interesting rocks that looking like ruins of old castle. But there never been castle there in that area on Southern Island of New Zealand. This formation was formed by long geological processes that operate in New Zealand for the last 20 million years. Let's talk in detail how it's formed, why we met these rocks in particular that area, and what it tells us about history and geology of New Zealand. We have to start from quite far back in time, when the New Zealand was not even on the map. Starting about 500 or 400 million years ago, the rocks which most of New Zealand consist of was just deposited in the bottom of the ocean, and from there New Zealand started birth. On our planet, the big continent Gondwana was still existing at that time, and we know it was the times of first fishes, first amphibians walking on our planet. At the same time, the big rivers were moving a lot of material from Gondwana, and it was all traveling down and deposited in the bottom of that ocean at that time. And that sediment, which mostly consists of quartz particles, very hard, nice silicon rock, which was deposited on the bottom in the area which today roughly area of Antarctica. Of course, at that time Antarctica was part of Gondwana as well. These layers of material was deposited, and then later it would start uplifting. Uplifting, it's mean bringing up towards the surface by tectonic processes, when two plates going toward each other and they're moving up the material. See my videos about plate tectonics, short video and a longer discussion about all the aspects of plate tectonic theory. We know for now the New Zealand uplift, which we called Orogeny. The first one, we name it Rangitata, but the name of the area in Southern Island, started about 200 million years ago. During that time, two plates collide. That time, remnants of Gondwana and area which we now know the Pacific Plate. They were moving towards each other, and all this sediment which deposited in the bottom of the ocean, which for previous 300 millions was very gradually deposited on the bottom of the ocean, start uplifting. We call these sediments Torles group in New Zealand. If you've ever been in New Zealand or look on the maps of New Zealand, everywhere we can see Torles group or Torles, Gravyaki deposits, you will know that's what it is. That's what I just talked about. This material that first deposited on the bottom of the ocean from Gondwana and then was uplifted. During the Rangitata, it's uplifted quite a lot, creating big mass of land. That time, dinosaurs were still dominating on the planet. About 100 till 50 million years ago, the Tasman Sea, which separates right now Australia and New Zealand, started formed, and we call it spreading. The Tasman started spreading in the middle, Australia pushing to the west, New Zealand to the east. It was the age of the Gondwana breaking off. Actually, some parts of Gondwana rocks we still can find on the west coast of New Zealand. That's why they're so different from the main Torles group you can see on the east. When the Tasman Sea filled, already first mammals appeared on the planet. The New Zealand rocks, which before uplifted during the Rangitata orogeny, they start a little bit moving down by erosion, and there was no more such a high uplift, so they start eroding and flattering down, becoming more like a plain surface. Later, about 25 million years ago, this process all stopped. And very, very flat New Zealand even sometimes was under the sea in places. It was so flat, the torless underneath, that it formed numerous shallow lakes and bays which were filled with warm water and organisms there. And that's the moment when the rocks which you see in the Castle Hill start forming. I know it's a little bit long introduction, but you have to understand all the process from the start to have a better picture how the limestone formed and why they preserved only in particular places. So majority of New Zealand was very shallow, you can see, and that time was prevailing Oligocene period on our planet, which characterized by quite warm climate. At that time, organisms thrived in the warm shallow seas of New Zealand. And erosion was not as high because we didn't have very, very fast uplift, which we observe now in southern Alps of New Zealand. So in these shallow basins, you have a lot of organisms who build in shelves, who have skeletons, living there, striving, eating nutrition which coming from the land. Therefore, the bodies, the skeletons, the shells, they start depositing on the bottom of these lakes and bays. And you know that the organism of animals, they consist of the calcium. Calcium is easier to dissolve or destroy than, for example, quartz rocks. And it's important to understand a formation of such interesting shape in Castle Hill. So layers of white calcium, crushed material was deposited on the bottom of these shallow lakes. And then second orogeny happening. Orogeny, the rise of the mountains. 25 million years ago, Kaikoura orogeny started. And during last 20 millions, and speed up quite a lot. And that's what we're observing right now in New Zealand, in particular Southern Island, with a large Alpine fold going through all the west, which is like a big crack just formed from too fast uplifting and squashing the material of the land, torless and other deposits. As a result, these shallow seas disappeared, they become uplifted up, and these thick layers of limestone, which is the rock which consists of the skeletons and shells and remnants of organisms prevailed of calcium, deposited. And it was all uplifted. You can understand that all these layers of torlos, this one that deposited 5, 4, 300 million years ago, squished, uplifted with the pockets of these lakes, which left this white, beautiful, but yet very easy eroded material, limestone. We're still in a Kaikoura orogeny, and if you've been in New Zealand in the last months, you experience huge earthquakes, and you understand that it's very, very active land. If you ever go to the mountains in New Zealand, you see a lot of erosion processes when the rocks fall apart, a lot of faults, a lot of landslides. But in places, in 20 million years, Tarlos uplifted quite high. If there was no erosion, if there was no rain or wind or earthquakes or landslides, the modern mountains will be about 20 kilometers high, but they're not as high. Average New Zealand mountains in the Southern Island about 2-3 kilometers maximum. So what's happened with these limestone pockets? Most of them been eroded. However, because uplifting or orogeny in mountains, it's not when you're just bringing everything up, you also push it from west and from east, maybe from south and north. So you kind of squishing rocks against each other, they get folded. And in some of these pockets, these limestones get preserved, kind of trapped between two turtles layers. And when they get exposed to the surface, they start gradually eroded. And that's exactly what's happened with Castle Hill. Castle Hill, and there's other places around New Zealand, in Timaru, Oamaru, somewhere around northwest of the South Island, where we have pockets of these limestones which preserved. But because they're made of these remnants of these organisms, skeletons and shells, they're very easy and sensitive react on rainfall. Therefore, they erode much faster and in a different way than surrounding turtles, which mostly consists of quartz. Therefore, when the rain falling down, it's combined the carbon dioxide in the air, which naturally exists in the atmosphere, and the water, making this kind of like a solution. We call it hydrochloric acid. It's very weak, but yet it works through years and years and hundreds of years and thousands of years and millions of years, and eroding this quite sensitive limestone. If you've ever been somewhere in Europe or anywhere else, or even Egyptian pyramid made of limestone, and you can see very rough surface of those pyramids and the blocks, just come closer, even take a little lens and have a look at the surface of those rocks. They eroded a lot, and they producing this kind of porosity on the surface. This is because they're made of limestone. The rain percolates through, dissolves some particles faster, some slower, in producing these features. Limestone's also the most famous to have the caves in, and in countries Bulgaria, Romania, Slovakia, anywhere else on the planet, if you go for huge caves with the big grots inside and lakes, it usually will be in the limestone deposits. If you look on the old granite rocks, which as same as age as limestone, for example buildings in the cities, they will have much smooth and clear surface. To erode those rocks, you need much longer time. Therefore, when we look on the Castle Hill, we see these beautiful features, like somebody created them, some kind of sculptor. No, the sculpture here was the nature itself. The rainfall, the snow, from years to years, and preferably eroded some limestone faster. The pure limestone, the less sand particles or other particles of other material in this limestone originally deposited, the purer it is, more whiter, brighter, and yet faster to erode. Some other limestones have a lot of sand particles. It's a little bit grayer or greener color. You can see the different shades of limestone. It might erode differently. If you have intermediate layers of sands in between, you might have kind of like a pancake structure, and so on. So the nature here play in different way and create all the different features. When it comes to the Castle Hill Basin and the sunset or sunrise, you even might see the figures of people, or big giants or trolls, or even faces, like somebody sculptured them. This is the game of our imagination and the way the light play with this. It's just showing you that the limestone eroded very intricate and in different forms and in different ways. And exactly for that reason, the Castle Hill Basin, very famous for used in movies, fantasy movies like Lord of the Rings or Chronicles of Narnia. If you rewatch those movies, be careful and look for the scenes which were filmed in Castle Hill. Climbers love that area, and tourists, of course, visited Castle Hill, not in quarantine times, regularly. But let's talk about geological aspects of that. So first of all, as I said, you can understand that in the places where we find features like that, it's not just amazing to observe or climb on, but it's also give you understanding on conditions which New Zealand went through during its formation, through its geological history. So you can know there was a period of time when the New Zealand wasn't as active as right now. There was no uplifting or orogeny, and at the same time there was a quite warm condition with a lot of shallow waters, and a lot of organisms lived there and deposited the remnants of the bodies in the bottom of the ocean. People around the world study places similar like Castle Hill Basin and reconstruct the palaeoclimate, paleontology on that area, so the organisms that used to live there, and also understanding the plate tectonic and how mountains and continents and plates moved on our surface. At the same time, the limestone play a crucial part in the carbon cycle around our planet. Thus, this organism, which limestone consists of, they were using carbon dioxide from the seawater, which originally come from atmosphere carbon dioxide, to construct the homes, the shells, or even parts of the bodies. And they also used the calcium dissolved in the seawater that originated as a product of erosion. That's to study that, to estimate volumes of limestone, how it's eroded, how fast it's come back when we eroded it back into the ocean, back into the system. We can estimate the carbon dioxide balance on our planet, which have effect, as we know, on climate. That limestone, which deposited in the bottom of the oceans, it's returning back to the atmosphere with a volcanic eruption. And we know, through the history, when we have a lot of volcanic eruption periods, there's a lot of carbon dioxide in the air. And then this carbon dioxide, with the rain falling down on the surface, eroding mountains, or even on the surface of the ocean, and then coming back to the cycle. However, places like Castle Hill Basin, they're trapping the limestone out of the system. For example, Castle Hill Basin limestone was formed from carbon dioxide 25-30 million years ago, and now for 30 millions it stays in form of rocks. Yes, it starts actively eroding now and coming back to the system, but it's a very slow process, and by the time it goes back to the ocean, back to through volcanic eruption into the atmosphere, it takes time. Therefore, climate on our planet will be not straightforward and always the same, and we have so many aspects of it, apart from astronomical aspects, which we talk about in previous videos, We also have a very big component of it. It's the plate tectonics, or how active the plates, where they are located and where they're moving right now at this period of time. We'll talk about that in the next videos. Stay with me. I hope one day you will visit the Castle Hill if you haven't yet, and you see for yourself how the forces of our planet creating beautiful and artistic features.